Okay, this is the fifth video that we're going to do for the class, and then we'll have homework assigned. Those already in the email. So basically, this is the question. It's example 5. It's a simply supported beam, reactions unknown, with a UDL across the top, 20 pounds per inch, and the entire length of the span is 18 inches. If you'll notice in the handout, this is exactly like case 4 here, right? So basically what this means is you can just not do exactly what I'm going to go through the hard way, and just with the values here, like for example, L is 18 inches and W is the UDL value, you can just plug in all that and find out that that peak moment there is going to be WL squared times 8. It's a shortcut. If you can get your beam to look exactly like this, you can use these shortcuts. We're going to do it the long way anyway. So what we have here, through inspection, right, we can see that this 20 pound per inch load across 18 inches is equivalent, when you do the free body diagram, that's equivalent to one concentrated load of 360 pounds acting right in the middle. If there's one load in the middle of two supports and it's 360, from inspection, I can tell that the reactions are 180 pounds apiece. Okay, so now what do we do from here, right? So let's do the shear like we did. So here, as in question 3, UDL goes down in a straight line from value to value. So here we know we're going to go a total of 360 pounds, right? Down, but we start out with a 180 going up to here, right? This is 180 pounds based on that reaction force. And we know during the whole UDL, we're going to go down a total of 360 pounds. So 180 minus 360 is minus 180. 180 minus 360 is minus 180. And we know that the UDL, let me try to get a ruler for that, because I'm going to draw a really not straight line. We're going to go straight down from there to there, right? And this should cross on this one directly in the middle, right? So we don't have to do any math there. We know if this is 18 inches, this one is going to be 9 inches going from here to here. If this had a different starting value, right, then maybe we got to find this out. But this is going to be right in the middle there, right? So it's going to be 9 inches. That's going to be 9 inches, okay? So, well, actually, you know what? I'm not going to say that. It is 9 inches, but I think we should do the math there all the time. So I'm going to leave this off. It's going to be 9, but I'm going to prove to you with our method that for now we don't know what it is, and we're going to have to add a different point. So anyway, on my shear, that's what we're going to have to work with, right? And they're not rectangular. Let's go ahead. We know we're going to call this area 1. And we're going to call this one area 2. If we were going to calculate the area of those right now, we wouldn't know the base. We know the height is 180 and 180, but we don't know the base. We don't know how long this is. We'll find it the wrong way. I mean the long way. Sorry about that. For the moments, as usual, let's go and revert back to the long drawn-out method. So the shear at A is equal to 180 pounds. That's based on this reaction force right there, 180, right? And MA, this is not a cantilever beam, so we know the moment at A is equal to 0. Always put your 0 in there. I did not. But we know we're going to start our moment value right there. Okay, at point B, we know that VB is equal to VA, right? Minus 360, that's the whole load of the UDL. Okay, right there. So we're going to get VB is equal to minus 180 pounds. And that's the shear load, shear force value at B. Duh, no big deal. Now, let's go back to addressing this question. Let's do it the proper way. So we want to ask ourselves, where does UDL cross x-axis, right? So let's say that the slope of this line, we're going to say the slope is the value of the UDL, so the slope is equal to 20 pounds per inch going down. That's the slope. And we said that we'll use for the equation of that line, we'll say that the starting value Sorry about that. Starting value minus the slope times x, right, equals 0. Or in other words, the starting value is 180, right? Minus 20 times x is equal to 0. Solve for x. X is equal to 180 over 20. X is equal to 9. Okay, 9 inches. That's how we know that this is now 9 inches. Don't assume it's always going to be in the middle. Sometimes all the start points and all the math don't work out so neatly. So be disciplined when you do that. So I have a point here, A and B. I have to find out what's going on. I want to get the moment here. But before I get the moment here, I have to find the moment here. So I'm going to add another point. This is A, that's B. I'm going to call this point C. That's going to be point C, right? So that's C. So therefore, I need to say at point C, right? The moment value of C is equal to the previous moment, so that's C. The previous moment is what? M at A, right? This area is above the curve, so I'm going to say that's going to be area 1. Here, what's area 1, right? We don't know that yet. So let's say MA is 0, right? And area 1 is base times height over 2. So the base is 9. The height is 180 over 2, right? So that's going to be 810 pound inches. So 810. So at MC, I'm going to be right there at 810. Now, this is first order, right? It wasn't 0 order. It's first order. It's a straight line. Therefore, this is a second order curve. This has got to be what? Parabolic. 810, right? And you would indicate that to me by saying second order. Even if you draw it as bad as I did, you would just say that's a second order curve, right? So now we want to find MB. We go back to here. So we can say that the moment at B, right, is the previous moment. So the moment here is equal to this moment. MC, right? This area is below the curve. So we're going to say minus, and that's going to be A2. Right? That's going to be equal to MC was what? 810. What's A2? The base is going to be what? This is, if this is 18, that's going to be 9. This is 180 or negative 180. We're going to say minus the base is 9 times 180 divided by 2. We should get this equal to 0. So once again, it's going to close off at 0. That's how you know if you've done it right. And once again, this is a straight line. Therefore, this has to be what? Parabolic. And you would say second order to indicate that curve is there. Now, you have your moment diagram. Where's your max moment? Right there. So your sigma is equal to MC over I. The whole point of doing this once again is to put that value there. Okay, that's the last of 5. 4 homework questions, I believe. I'll post the solutions for those at the start of the next class. All the homework solutions, all the homework problems are due by Sunday evening, right? I'm giving it to you on Wednesday, and they're all due on Sunday evening. So please have those emailed or posted in Blackboard, whichever you prefer, and I will post the solutions on a video for Monday's class. Okay, thanks.